can work out some problems on these beams, plane trusses as well as plane frames in the tutorial class. So here first one beam problem, similar type of problem I have worked already. You can just try all this. This is one problem. A, B, C, D. So 80 kilonewtons, 80 kilonewtons, 50 kilonewtons per meter. This is each is 2 meters. So of course you can take here as constant. So find bending moment and shear force at C and D, and also draw bending moment diagram. So using ILD, influence line diagram. So both you can just try conventional method as well as using ILD. You can just first find MC, MD, and MA, MD are 0. You can just, because you know the variation is always straight line, you join, you will get the bending moment diagram. Similarly, shear force also. This is on beams. Then, by method of joints, so you can solve these problems on the trusses. Only determinate analysis of determinate beams, plane truss and plane frames. So this you can analyze, and of course by method of joints, because simple problems you can always do the analysis by method of joints. 20 kilonewtons, 10 kilonewtons, or this you can take 50 kilonewtons and 20 kilonewtons, 3 meters, 4 meters. And third, you can take this. A truss, plane truss, this 1 meter, 2 meters, and this 2 meters. So you can have just one load, 20 kilonewtons. So either we can give angle on one side or the length of all sides. So another, this is by method of joints. Find forces in all members of truss shown in figures 2, 3 and 4 by method of joints. Method of joints. You can take one more truss. Of course, this is straight. Of course, I told you it is same as 60 degrees. One side and that is load. So these three you can analyze by method of joints. The procedure already I had given. First step, you have to find the reactions of the supports, because they are all determinate type of problems only. You apply 3 equations of statics. Sigma m, one of the support 0, you can determine one vertical reaction, and sigma v 0 other reactions, as well as sigma h is equal to 0. If at all the horizontal load is there, you will get horizontal reaction. Always you will have one hinge support on the roller support in determinate type of structures. Horizontal reaction you will get only at hinged support. Whatever horizontal reaction or load is given, that straight away it will go full capacity at that particular support only. In roller you will have only vertical. So by applying sigma h equals 0, you can find the horizontal reaction at hinged supports, and by taking moment at one of the support, that is hinge support, you can determine the vertical reaction at roller. Another by sigma v equals 0, you can determine that. So like that, first you determine the reaction, then you select any joint has not more than 2 forces, take that joint, draw the free body diagram, apply 2 equations of static, sigma h equals 0, sigma v equals 0, evaluate the forces. You have to resolve the forces correctly by determining the angle of inclination. So then you select the next joint, wherein again not more than 2 members are there. Like that you go on repeating, and by selecting all joints, various joints in the structure, wherein not more than 2 nodes are there until all member forces are determined. First, always you take all member forces to be tensile force to start with. Then at each joint you analyze it. If it becomes negative, you write that negative value in the first step. In the another truss, you just reverse it arrow and then enter it. In the other sketch, you will know how many members have been determined. So like that, you can just have it. To start with, always take all tension positive. So of the free body diagram, drawing the free body diagram and evaluating, if the value is negative, then in one more sketch you show that arrow opposite direction, otherwise retain it. So go on just entering the forces with correct arrow in one more sketch. But to start with, always you take tension and do that. So that's all the procedure you have to follow. This is what is taken. Then if say this is 4th problem, then 5th problem, you can analyze the truss by method of sections as well as by influence line diagram. Using influence line diagram, we can take first this truss. By method of section, you draw and determine the forces first, and then using influence line diagram also, you can analyze it. So you can take this is 60 degrees, 60 degrees, 60 degrees, 60 degrees. Height you can take it as 2 meters, force. So in this, when you are using influence line diagram, loads has to be either only vertical, gravity loads, not horizontal. So that, thank you. So 20 kilonewtons, and this all will have 20 kilonewtons. Or it can be different also. One discuss, another each load is 30 kilonewtons. This panel length, you can take it as 4 meters, 4 meters, 4 meters, 4 meters. Height you can take it as 3 meters. So you can determine the forces, find forces in coil and well members by method of sections and using ILD both. You can by method of sections also you can solve, because here you can take one section, another section, we will analyze all the forces. And similarly here you can take this and this, because I have given symmetrical load, only one half you can analyze, other half will be symmetric. Here also you can take that and you can analyze by taking two sections, here also 2 or 3 sections, and evaluate all the forces by method of sections only to start with. The conventional methods by applying the 3 equations of equilibrium. Then you can use the influence line diagram also for both type of tests. This is flat type, this is variant type. So I have covered all these things, method of analysis of trusses as well as beams. And then this is another extra thing. You can analyze or draw BMD for the frames shown below. So one, you can take this. Of course, again, determinate only. So that means you should, one end support should be hinged, other should be roller. You can take one this. This you can observe, it is just similar to the beams. When load is acting only on the beam member of the frame, this is beam member, this is column member. When load is acting only on the beam member, then you will get the bending moment diagram only similar to beam. Only the beam member you have to draw the bending moment. It is similar to this beam problem. Whatever supports you have here, that is replaced by column. That's all. It is similar to a beam, nothing other than that. So you can take number of sections here, 3 sections in each of the members, take free body diagram on one side and find out the bending moment about that section, draw the bending moment diagram. In this too, if you take it, because reactions will be only vertical. Load I have given only vertical load. So you will get reaction here only vertical. The span can take 6 meters, height 4 meters, here also 4 meters, 4 meters, 2 meters, 4 meters. You can take, and of course here is constant. So if you take 2 sections here, if you take the free body diagram towards this side, bending moment about this section will be 0, because this will not contribute anything. So then Mx is equal to 0, therefore when x equals 0 and x equals 4 meters, there won't be any moment. Same thing here also. Only you will get, you take a section here, get the moment equation, you will get the bending moment diagram. So here you will get bending moment diagram only like this, here only like this, you can check. Here you don't have. Though frame is also similar to that. I have set a problem on frames also, there is nothing. But if you have a horizontal load, then you will get a horizontal reaction. Due to that, you will get the bending moment diagram for that also. So if you want, you can try that problem also. Either like this, one end hinge, another free. Similar to cantilever, you can take a problem like this. 20 kilonewton per meter and 20 kilonewtons, 6 meters, 4 meters. So this is C. So this problem you can solve. I have given full instruction. And then static analysis I have told. We are determining only the support reactions and internal member forces, shear force and bending moment. Here mainly bending moment. Shear force I have asked only for the beam. Here also you can draw shear force, but bending moment is the main concern. Here of course trusses is only the axial force or the tension forces in all the members of the truss only we have to determine. So this is what we have covered in Unit 1 of the syllabus. Analysis of determinate frame structures. Static analysis. Kinematic analysis, that's evaluation of displacement. It will be, we will cover it in Unit 2 and 3 by strain energy method, cosmology, moment area. 2 and 3. They are mainly confined with kinematic analysis, again of same type of problems, plane truss, beams and frames, rigid frames. That's all you have in your syllabus. Unit 2, 3 covers kinematic analysis, Unit 1 static analysis, Unit 2 also static analysis but for moving loads. So your 80% of the syllabus mainly covers the static and kinematic analysis of these frame structures, determinate plane frame structure. Simple structures, it is nothing. And of course, indeterminate will be finished. And last unit is arches and cables. So we will cover now the analysis of these determinate structures only when they are subjected to moving loads. That we will take up now. If you continue.